Good morning students. In this video we are going to see Unit 8 sound from page number 96 to 98. Learning objectives: understand the concept of echo and reverberation, know about ultrasonic sound and the applications of ultrasonic sound, understand about sonar and ECG, know about the structure of human ear. Echo. What is called echo? When we shout or clap near a suitable reflecting surface such as a tall building or a mountain, we will hear the same sound again a little later. This sound which we hear is called an echo. See this diagram. A person is clapping. This sound hits the wall and then reflects back. So it is called as echo. So when we shout or clap near a suitable reflecting surface, it is a reflecting surface such as a tall building or a mountain, we will hear the same sound again a little later. This sound is called an echo. The sensation of sound persists in our brain for about 0.1 second. Hence, to hear a distinct echo, the time interval between the original sound and the reflected sound must be at least 0.1 second. The sensation of a sound persists in our brain for about 0.1 second. About 0.1 second only we have to hear the sound. So here the distance between the time interval and then the original sound and the reflected sound must be at least 0.1 second. See this diagram, it is the original sound and it is the reflected sound. So the time interval between these two sound must be at least 0.1 second. Let us consider the speed of sound to be 340 ms-1 at 25 degrees Celsius. See this diagram. The speed of the sound must be 340 ms-1. The sound must go to the obstacle and return to the ear of the listener on reflection after 0.1 second. When it will return to the listener? After 0.1 second. Now the total distance covered by the sound from the point of generation to the reflecting surface and back should be at least 340 ms-1 into 0.1 second is equal to 34 meter. So let us consider the speed of sound to be 340 ms-1 at 25 degrees Celsius. The sound must go to the obstacle and return to the ear of the listener. When it will return to the listener? After 0.1 second. Now what is the distance covered by the sound? The distance covered by the sound is equal to speed into time. So what is the speed? 340 ms-1 into time is 0.1 second. Now here second and s-1 get cancelled. Now when we multiply 340 and 0.1 we get 34 meter. So the distance covered by the sound is 34 meter. Thus, for hearing distinct echoes, the minimum distance of the obstacle from the source of sound must be half of this distance, that is 17 meter. Now here the distance travelled by the sound is 34 meter. That is both the reflected and then original sound wave is 34 meter. Now the distance travelled to the obstacle is 17 meter. So that is half of the distance. Now this distance will change with the temperature of air. These echoes may be heard more than once due to successive or multiple reflections. When the echo will change, when the echo will heard only after the successive or multiple reflections. What is called multiple reflection? It is the reflection of light back and forth several times between the two reflecting surface. That is, when the light ray reflected between two reflecting surface for several times, it is called multiple reflections. The roaring of thunder is due to the successive reflections of the sound from a number of reflecting surfaces such as the clouds at different heights and land. That is, the reflections takes place between the cloud and the land is called roaring of thunder. So here the successive reflections will take place, or the multiple reflections takes place between the cloud and the land. Reverberation. What is called reverberation? A sound created in a big hall will persist by repeated reflection from the walls until it is reduced to a value where it is no longer audible. The repeated reflection that results in this persistence of sound is called reverberation. See this diagram. The reflection takes place between the two walls. And then here the reflection takes place as a repeated reflection until it is reduced to the value where it is no longer audible. See the arrow mark. So it will reduce to no longer audible. So this repeated reflection that results in the persistence of sound is called reverberation. What is called persistence? Persistence means the continued or prolonged existence of something. It is called persistence. So what is called reverberation? A sound created in a big hall will persist by repeated reflection from the walls. See this diagram. Here the repeated reflection will take place from the walls until it is reduced to a value where it is no longer audible. In an auditorium or big hall, excessive reverberation is highly undesirable. Undesirable means what? Unpleasant. So to reduce reverberation, the roof and walls of the auditorium are generally covered with sound absorbing materials. The roof and walls are covered with sound absorbing materials like compressed fiberboard, flannel cloths, rough plaster and draperies. The seat materials are also selected on the basis of the sound absorbing properties. So in auditorium, the sound absorbing materials are compressed fiberboard, flannel cloths, rough plaster and draperies. The seat also selected with sound absorbing properties. Ultrasonic sound or ultrasound. What is called ultrasonic sound? The ultrasonic sound is the term used for sound waves with frequencies greater than 20,000 Hz. If the frequency is greater than 20,000 Hz, it is called ultrasonic sound. These waves cannot be heard by the human ear, but the audible frequency range for other animals includes ultrasound frequencies. So here the dog, for example, we have to consider the dog can hear ultrasonic sound. Ultrasonic whistles are used in cars to alert deer to oncoming traffic so that they will not leap across the road in front of the cars. Uses of ultrasonic sound. An important use of ultrasonic sound is in examining inner parts of the body. It is used to allow different tissues such as organs and bones seen or distinguished in our body by bouncing of ultrasonic waves by the object examined. The waves are detected, analyzed and stored in a computer. These ultrasonic waves are detected and also analyzed and stored in a computer. An echogram is an image obtained by the use of reflected ultrasonic waves. So echogram is an image used by the ultrasonic waves, the reflection of the ultrasonic waves. What is called echogram? It is a test that uses sound waves to produce the image of our heart. It is used as a medical diagnostic tool. Ultrasonic sound is having application in marine surveying also. More to know. Animals such as bats, dolphins, rats, whales and oil birds use echolation, an ultrasound technique that uses echoes to identify, locate objects. What is called echolation? Echolation is a physiological process for locating distant or invisible objects by means of sound waves reflected back to the emitter by the object. That is, echolation is the physiological process for locating distant or invisible objects by means of sound waves reflected back to the emitter by the objects. So this echolation allows bats to navigate through dark caves and find insects for food. See this diagram. Here the Bat used this echolation to find out the insect for food, and dolphin and whales also use this to emit a rapid series of underwater clicks in ultrasonic frequencies to locate their prey and navigate through water. Application of ultrasonic waves. Ultrasounds can be used in cleaning technology. Minute foreign particles can be removed from objects placed in a liquid bath through which ultrasound is passed. This ultrasound is used for cleaning technology. When we want to clean the object, we have to keep the object in a liquid bath. The ultrasound is passed and then it removes the foreign particles. Ultrasound can also used to detect cracks and flaws in metal blocks. How it is used to detect cracks and flaws in metal blocks means the ultrasonic waves are allowed to pass through metal blocks and detectors are used to detect the transmitted waves. If there is a crack in metal block, these waves get reflected back, thus indicating the presence of defect or flaws like cracks in the metal block. How it is used? It is used to pass the ultrasonic wave through metal blocks, and detectors are used to detect the transmitted waves. If there is a crack in metal block, these waves get reflected back, thus indicating the presence of defect or flaws like cracks in the metal block. Ultrasonic waves are made to reflect from various parts of the heart and form the image of the heart. This technique is called echocardiography. What is called echocardiography? The waves, that is the ultrasonic waves, made to reflect from various parts of the heart and form the image of the heart. This technique is called echocardiography. Ultrasound may be employed to break small stones formed in the kidney into fine grains. If there is a stone in a kidney, this ultrasound is used to break the stone in a kidney. So the stone is break into fine grains, and then these grains later flushed out with urine. Sonar. What is called sonar? Sonar stands for sound navigation and tracking. Sonar is a device that uses ultrasonic waves to measure the distance, direction and speed of underwater object. So what is a sonar? It is a device used to measure the distance, direction and speed of underwater objects. The sonar consists of transmitter and detector, and it is installed at the bottom of boat and ship. See this diagram. The sonar consists of transmitter and detector. It have two parts, transmitter and detector, and the sonar is installed at the bottom of a boat on ship. Now here the transmitter produces and transmits the ultrasonic waves. Which one produces the ultrasonic wave? Transmitter. Now these waves travel through the water and after striking the object on the seabed get reflected back and are sensed by the detector. So which one is sensed the reflected wave? Detector. Transmitter transmit the ultrasonic wave, detector detect the ultrasonic wave. Now this detector convert these ultrasonic waves into electrical signals which are appropriately interpreted. So how the sonar is working in a boat and ship? Here it has transmitter and a detector. The transmitter transmits the ultrasonic wave and a detector detects the ultrasonic wave and then it converts it into electrical signals. The distance of the object that reflected the sound wave can be calculated by knowing the speed of sound in water and the time interval between transmission and reception of the ultrasound. How can we calculate the distance of the object? We can calculate the distance of the object by knowing the speed of sound and then the time interval. Let the time interval between transmission and reception of ultrasound signal be t. We can consider the time interval is t. Then the speed of sound through seawater is 2d by t is equal to v. See this diagram. The speed of sound through seawater is 2d by t is equal to v. Electrocardiograph. What is called electrocardiograph? This electrocardiogram, that is ECG, it is one of the simplest and oldest cardiac investigations. It provides a wealth of useful information and it remains an important part for the assessment of cardiac patients. In ECG, the sound variation produced by the heart is converted to electric signal. See this diagram. Here the sound variation in our heart is converted to electric signals like this. Now, thus an ECG is simply a representation of the electrical activity of the heart muscle. This diagram is the electrical activity of the heart muscle and it changes with the time. For every second, the heartbeat will changes. Now, usually this electrical activity is printed on a paper for our easy analysis. See this diagram. These electrical signals are printed in the paper. Now the sum of this electrical activity which amplified and recorded for a few seconds is known as ECG. Structure of human ear. How do we hear? We are able to hear with the help of extremely sensitive device called the ear. It allows us to convert pressure variations in air with the audible frequencies into electric signals that travel to the brain through the auditory nerve. See this diagram, it converts the pressure variations in air with audible nerves. Here the audible nerves send the signals to the brain. It is called as a human ear. Now let us see how the auditory aspect of human ear will take place. Function of human ear. The outer ear is called a pinna. What is called outer ear? It is called pinna. It collects the sound from the surroundings. The collected sound passes through the auditory canal. Where the collected sound will pass, it passes through the auditory canal. At the end of the ear is eardrum or tympanic membrane. See his diagram. At the end of the ear, we have eardrum or tympanic membrane. When the pressure on the outside, that is when a compression of the medium reaches the eardrum, the pressure on the outside of the membrane increases and forces the eardrum inward. When the compression increases, it forces the eardrum inward. See this diagram. Here the eardrum is forces inward. When it forces inward, when the compression increases, we already know that compression means high pressure region. When the high pressure region takes place, it forces the eardrum inward. Now the eardrum moves outward when the rarefaction reaches it. Rarefaction means low pressure region. When the low pressure region takes place, the eardrum moves outward. In this way, the eardrum vibrates. How the eardrum vibrates? When the compression of the medium reaches the eardrum, the pressure on the outside of the membrane increases and forces the eardrum inward. Similarly, the eardrum moves outward when a rarefaction reaches it. In this way, the eardrum vibrates. These vibrations are amplified by several times with the help of the three bones present in the middle ear. Where the three bones are present? In the middle ear. What are the three bones? The hammer, anvil and stirrup. Now the middle ear transmits the amplified pressure variations received from the sound wave to the inner ear. In the inner ear, the pressure variations are turned into electrical signals with the help of a cochlea. Now these electrical signals are sent to the brain through the auditory nerve and the brain interprets them as a sound. So here the middle ear transmits the amplified pressure variations received from the sound wave to the inner ear. Now this inner ear pressure variations are turned into electric signals by the cochlea. Now these electric signals are sent to the brain through the auditory nerve. Now echo. What is called echo? When we shout or when we clap, the sound transmits within a letter is called the echo. So when we shout or clap near a suitable reflecting surface such as a tall building or a mountain, we will hear the same sound again a little later is called echo. Reverberation. What is called reverberation? A sound created in a big hall will persist by repeated reflection from the walls until it is reduced to a value where it is no longer audible. This repeated reflection that results in this persistence of sound is called reverberation. Ultrasound. What is called ultrasound? It is a term used for sound waves with frequencies greater than 20,000 Hz. Application of ultrasonic waves. Where the ultrasonic waves are used, it is used for cleaning technology. It is used to detect cracks and flaws in metal blocks, and also it is used in echocardiography, and also it is used to break small stones formed in kidney. Sonar. What is called sonar? It is a device that uses ultrasonic waves to measure the distance, direction and speed of underwater objects. Electrocardiography. It is one of the simplest and oldest cardiac investigations. Structure of human ear. The outer ear is called pinna. This pinna only collects the sound from the surroundings. This collected sound passes through the auditory canal, and then at the end of the ear is eardrum. When the compression of the medium reaches the eardrum, the pressure on the outside of the membrane increases and forces the eardrum inward. When the pressure decreases, the eardrum moves outward. In this way, the eardrum vibrates. Now, the vibrations are amplified several times by three bones present in the middle ear. The three bones are hammer, anvil and stirrup. Now, the middle ear transmits the amplified pressure variations received from the sound wave to the inner ear. In the inner ear, the pressure variations are turned into electrical signals. These electrical signals sent to the brain through the auditory nerve, and the brain interprets them as sound. Thank you, students.